Hey guys, today we're going to talk about 4.2 congruence and triangles. I've already got my notes handout cut and placed on the page, so I'm going to show you that real quick, and you can go ahead and get yours cut out and placed on the page. So you may want to pause the video and then get this cut out and then come back here in just a few minutes. Alright, hopefully you have this cut out and taped down or glued down, however you're going to do that. Today we're going to start talking about congruence and how that relates to triangles. Congruence seems like a pretty simple idea because, congruent is congruent. It's same as, it's equal to, we've talked about it a million times, so it seems like a fairly simple idea. But we're going to talk about congruence as it relates to shapes, and we're going to get a little more deep into that, especially involving triangles, because there are so many things that we can do in geometry when we know that triangles are congruent. So what exactly is congruent? Let's say we have these two triangles right here, triangle ABC and triangle GEB. Clearly, by the eyeball postulate, they look congruent. Alright, they very much look congruent. Everything about this triangle looks exactly the same as everything about that triangle. And so what we call those, we call the pieces corresponding. So we've got three corresponding sides, and we've got three corresponding angles. So we're going to list all those out right now, which sometimes seems a little painful, but we're going to do that here just so that we identify exactly what is congruent about these two triangles. Alright, so let's start out with the sides. First of all, we're going to say that side AB, line segment AB, is congruent to line segment GB. Alright, so we'll put one little mark on each of those to show that they're congruent. I'm going to zoom in on that just a little bit so you can see better what's going on. Then we want to say that line segment AC is congruent to line segment GE. So we are talking piece by piece, what parts of these triangles are congruent. And then last, BC, line segment BC, is congruent to line segment DE. Alright, and those are the three corresponding sides. Now we do have, the reason they're corresponding is because this side goes with this one, and this side goes with this one. So that's just like corresponding angles on parallel lines, we have corresponding sides. Sides that go together, sides that are a pair, they're a match. So corresponding angles would then be angle A is congruent to angle G, right here, and then angle B would be congruent to angle D, and then last but not least, angle C is congruent to angle E. So I put three little marks there and three little marks there to show that those sides are congruent. So, in general, congruent figures have the same shape and size. They have correspondence between angles and sides. Alright, so everything about them is the same. So over here, when two figures are congruent, there is a correspondence between their angles and sides such that corresponding angles are congruent and corresponding sides are congruent. Alright, so that basically defines what it means to be congruent. All the sides are congruent, all the angles are congruent. So the way we would name these angles now, name these triangles now, is we would say triangle ABC is congruent to triangle, and the A corresponds to the G, so I have to put the G first. The B corresponds to the D, so I have to put it second. And the C corresponds to the E, so it has to be last. So the order of your angles has to match based on what they correspond with. A goes with G, so they're first. B and D they go together, so they're second. And C and E go together, so they're last. If you mix those letters up, you actually miss it. So make sure that you always correspond your letters, write them in the same order. So what we call that is pretty nifty. That's a lot to have to say every time we want to prove something. So what we call that is we call that CPCTC. And that stands for corresponding parts of congruent triangles are congruent. And so whenever you, in a proof, you have proven that you have congruent triangles, which you'll do that a lot. We're going to try to prove triangles are congruent. After we know that they're congruent, we say the reason is because corresponding parts of congruent triangles are congruent. Okay? Or if you know the triangles are congruent, then you're going to use this. Alright, let's put that down, because I want to make sure that's perfectly clear. I'm not sure I made that clear. When you know that triangles are congruent, then use CPCTC. Alright, I'm going to outline that, because that's pretty important. When you know that triangles are congruent, then we can use CPCTC. If the triangles are congruent, then their angles are congruent, then their sides are congruent. So it's sometimes in a proof, you can use that. Now that you know that the triangles are congruent, you can start piecing them out. Like you can say, well, since the triangles are congruent, then these two sides are congruent. Since the triangles are congruent, then these two sides are congruent. And you can use those in the rest of the proof if you need to. Alright, well, we're going to talk about the third angle theorem then. The third angle theorem is this. If two angles of one triangle, are congruent to two angles of another triangle, comma, then the third angles are congruent. That's are congruent. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So basically what you're given here is angle A is congruent to angle D. And let's draw that. Draw a picture of, we'll call this angle ABC. And then we'll have another triangle. Try to draw them congruent. I didn't do a very good job. We'll call this DEF. Alright, if two angles are congruent if two angles of this triangle are congruent to two angles of this triangle, so we're going to start off with A is congruent to D. And then I'm also going to give you angle B is congruent to angle E. Alright, you're going to be given that. Put two little marks on those. So we're going to prove that the third angles are congruent. So we want to prove angle C is congruent to angle F. Alright, that's what we're going to try to prove. So we've got the proof all set up here. Let's go ahead and get it started. Number one, of course, is the given. Angle A is congruent to angle D, and angle B is congruent to angle E. That's given. Now, if you want, you could go ahead and just pause the video and see if you can't figure that out on your own. I will tell you that step 7, this is a 7-step proof, and it does end with angle C is congruent to angle F. Alright, I'm not going to tell you the reason there, but if you want, you could pause the video and go ahead and try to do this on your own. Or maybe you can go step by step and get some hints and then see if you can do it. Alright, but number 2, here we go. There's not too much we know about triangles other than maybe that their angles add up to 180. So why don't we just start out with the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. That's pretty much all we know, honestly, about a triangle. So, and we just know that that's angles of a triangle equal 180 degrees. Okay, we know that. Then number 3, and that was from the last section, 4.1, so you should have that in your notes. Then step 3, since we know that A and B are equal to D and E, respectively, then in place of the A, we can put in a D, and in place of the B, we can put in an E. And that's just a little substitution. So now that we've got those figured out, we've got D, E, and C, then what we can do is we can think about the triangle on the other side. We know that D, E, and F also add up to 180. D, plus the measure of angle E plus the measure of angle F. We know those add up to 180. If you look right over here, those are the 3 angles of that triangle. So again, angles of a triangle equal 180. Alright, now since these both equal 180, we can set them equal to each other. So the measure of angle D, I'm looking at step 3 and 4, plus the measure of angle E plus the measure of angle C equals the measure of angle D plus the measure of angle E plus the measure of angle F. And we'll call that substitution. Alright, because they both equaled 180. Now, check this out. You got D's on both sides, so we can subtract the D from both sides. We can subtract the E from both sides, and what that leaves is the measure of angle C equals the measure of angle F. The measure of angle C equals the measure of angle F. Step 6, that is the subtraction property of equality. And then, of course, changing it, going from measures into a congruent statement is just the definition of congruence. So really, that's not a hard proof. If you look at what you're given there and you just kind of go from there, you just kind of piece it together. Alright, now these properties should sound familiar because we've done them 100 times. These are your properties of congruent triangles. Alright, we've done reflexive, symmetric, and transitive so many times now. I think you should be pretty familiar with it. But when we're involved in triangles and when we want to try to relate these to triangles, this is the way it sounds. First of all, the reflexive property says that every triangle is congruent to itself. That seems like a no-brainer. Remember, before it was like A equals A, B equals B, or maybe line segment AB equals line segment BE. Everything equals itself. Symmetric property when we're relating to triangles says if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. So symmetric property, remember, just flip-flops it. Okay? Flip it over. Very good. And the transitive property, oh my goodness, is the same as it's always been. If triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle GHI, then triangle ABC is congruent to triangle GHI. Alright, whoa, sorry there, I got off the page a little bit. Let me move that up so you can see it. Alright, transitive. If triangle ABC is congruent to DEF and DEF is GHI, then triangle ABC is congruent to GHI. Alright, that is it for this video. Hopefully you got it all down, and we will see you in class.